Hi everyone, thank you for having me again. It was a real privilege being here with you all last year, and this year I'm building on the theme of how to make your data-viz life easier by optimizing your data-to-viz workflows. And this time we're going to be talking about building parameterized plots. The main aim for today, we're going to build a basic ggplot, we're going to give it a bit of style, and then we're going to parameterize it so that we can start playing around, feeding it different bits of data and asking different questions of it. So without further ado, let's get started. Here is our starting point. I'm going to load the tidyverse because we're going to be using ggplot and a few of the functions that are within the tidyverse to help us manipulate data. The data that I'm using is the Palmer Penguins dataset, and this is so that you can go ahead and reproduce this at home. I'll be posting the code for this on my website at the talks page. So we're loading the penguins data in, feeding it into ggplot, and then we're using geom_point to map bill length against flipper length, and we're going to color it by species. We've decided that we want the points to be size 5, and we're giving them all a bit of transparency so that if there are overlapping points, we can see that that's happening. We're then going to give it a title about the flipper lengths and bill lengths being proportional to each other, and then we're going to label our axes. So here we have our first plot, which is a standard ggplot as we've come to know and love it. I think we can make it look a bit better than this, so let's see what we can do. The first thing we're going to do is we're going to use theme minimal, and the next thing I'm going to do is add in some colours. So I'm going to add in a kind of amber for the Adelis, a cherry blossom pink for the chin strap, and a green for the Gentoo. So we've got the colours set in. But this is kind of the quick way of doing it, which isn't necessarily the wisest way, and I'll show you why in the next slide. So here we've got the full data, and if we decide to just narrow it down to the top 200 penguins, then we're losing a species because not all the species feature in the top 200. But the thing that you'll notice here is that what used to be green, the Gentoo, has become pink. So the colours, although we've not changed anything else in the code, the colours have started to switch around. So we need to make sure that doesn't happen, and so here's my mini tip number 1, which is to use named vectors for colours. If you've seen me give a talk before, you've seen this before, but so many people find it helpful that I thought I would just reiterate it here while I have a chance. We're going to create a named vector called penguin colours, which is this here, and it's named. So we're going to say that Adeli equals orange, and chin strap equals pink, and Gentoo equals dark green, and then we're just using that inside our plot down here. Just highlighting this line. So we've got the penguin colours that are coming in here, and this is with the full data as we had used at the start, but you'll see that now if we swap that for just the top 200 penguins, the colours still stay in the right place. So if you're thinking about parameterizing anything and changing your data and you've got colours in your plot, highly recommend doing this. The next thing that I think it would be worth doing to make this plot look a bit nicer is to invest in our own custom theme. We don't really have time today to go into the details of that, but you can find out more at my talks page, and I've put a link down here to the variations on a GG theme talk that I gave at the NHSR conference if you want to look into that. We've got the plot that we had earlier, and then we're adding theme demo here, which is the theme function that we've just created, and this is what it looks like. So before we start parameterizing this, I thought we should add a few annotations in. So we've got some GG text going on here, which is one of my favorite packages to use in R and ggplot. I use it in most of my plots. Marquee, which is a new package, was released the week of recording this, so I haven't changed my code in the talk, but it is definitely a package to be looking out for future talks. We've got our 3 labels, and the way that I've placed them here is simply that I've calculated what the mean bill length and the mean flipper length is for each species. We can then feed that into the plot here within the text box. So now that we've got the basic mechanics, we can start pasting stuff in. So we can use the double asterisk to make the species bold. And then this is just a line break, and we're going n equals and counting. So just a fairly basic label for now, just so that we can see what we're doing with our annotations. After this point, we can add other things in. So let's say we wanted to also say what the mean weight was, and we can calculate that above, and then we can feed it in again into the label. So now let's just do a bit of styling. We've got size equals 7, which we had earlier. We've fed in a font family. We're saying what width we want the box to be. So there we go. In all of this, we have gone from something that was fairly basic and not styled to something that is now styled and even annotated. And to use the analogy of the squirrels that we had earlier on, this is what we've done. So the first way that we're going to make our parameterized plot dance is to feed it some different data. You've created your first plot, you've got it all sorted, you're running up to the meeting, and then suddenly your colleague says, actually, sorry, I just wanted the first 200 penguins. You say, okay, that's okay, no problem, I can do that. So you go into your code and you think, right, okay, I'll just take the top 200 penguins that we've got here, feed that into the mean XY calculation, and then I'll also just take the 200 and feed them into the plot. That's fine. We can do that, not a problem. Here we go, and look, all the annotations are in the right place, and the colours are as they should be, and yay, all is good. And then they say, actually, sorry, could we do both for comparison? Sure, no problem. I'll just copy paste that, and that's okay. We can do that. And then actually, could we also check with 300 and 400? Oh, okay. Yeah, I'll just copy paste that again. And before you know it, what was some fairly straightforward code has just become lots and lots of copy pasted bits of code. It's all over the place. And you're going to get the plots done and it's fine, but you're aware that it's not ideal. And then comes the problem that they come over to you and they say, I know it's 5 minutes before the meeting, but I really don't like those fonts and those colours. Could you possibly change them? And you find yourself frantically typing away, trying to figure out, have you got the right lines of code here? Is this the right stuff that I'm changing? How am I going to make sure that this gets done on time? You get to your meeting, you're looking at the slides that are up there on the big screen for everyone to see, and you're thinking, something's not right. I've copy pasted something in the wrong place. That label does not match those values. What we're trying to do here is save you from that scenario so that you can go straight to answering the questions without having to copy paste anything anywhere. When I mentioned to someone else that I was preparing this talk, they highlighted that you could maybe just use the replace function and replace the data. So it's true, you can create a plot. You've got it here. We've got a penguin plot that we've created, fitting the Palmer penguins data in, doing all the same styling that we did before, and then if we call that plot, this is what we get, which is what we were expecting. And we can then simply replace the data by using the replace function here. And instead we say, okay, this time, rather than using Palmer penguins, the whole thing, we're just going to use the top 150 penguins, and we get this. And you can even do stuff like filtering it on the way in. So you can modify your plots like this. But I think we're going to be looking to do something a little bit more sophisticated, specifically with the annotations that we'd added in. We want to make sure that we can carry those across if we want to, and also that we can do a few more fun tricks with our plot. So the replace function does work, but there are other things that we can do just to make it a little bit safer for ourselves when we're creating these plots. So let's remind ourselves, here was our starting point. We've got a mean X and Y, and we've got the Palmer penguins, and all of this is getting combined to create the plot that we've been seeing. All we need to do is turn this into a function that we're going to call make penguin plot, and we're going to make it into a function by putting the word function here, and then opening up the brackets to feed in the arguments. So in doing this, I should highlight mini tips 3 and 4, which are to do with defaults and environments. When you're writing your functions, you want to write them in such a way that they don't need to pull anything from the outside world, from the world outside of themselves. So we're going to feed it the data frame that we want to use, which is the Palmer penguins data, and then you can see that we end up using that all the way through. The other thing that we can do is create defaults. And in this case, we're going to create a default color. So we've got our color defaults, which are the penguin colors. And we could change those if we wanted to. If, say, you wanted to have, red, green, and blue penguins instead, then that's an option. But having the defaults there means that you don't need to specify the colors every single time. So we've got our function that we've created, and now all that we need to do to see the original plot is call this one line of code, which means that then when your colleague comes and says, actually, could we do it with the first 300 and the first 400 penguins? You say, yes, no problem, here you go. And you're just copying one line of code every time, which means that then if they come to you 5 minutes before the meeting and say, can you change the fonts? You're only changing them in one place. If they then come to you and say, actually, could we do it by island instead? Then again, you can say, yeah, that's absolutely fine. Let me just filter it. So then instead of feeding in the top 400, you're just filtering the Palmer Penguins dataset to say that you filter for when island equals dream on this side, or for when island equals bisco. The next way that we can parameterize our plots is by specifying different groupings for how we want to organize the data. So here we have our function again, and we can see that what we're wanting to do here is this time maybe try and group it by species rather than grouping by island. So let's see how we need to rework this to make that happen. We need to add a grouping variable, and we're going to say grouping variable equals species. And then we're going to try and feed that in to the grouping variable here and count the length of that grouping variable, and then in the plot we're going to paste that grouping variable in again. This doesn't actually work. If you do this, you end up with this error message that says that it can't find the column grouping variable in the data. And so there is a fix to this, and the easy fix is to use get. So if we use get and wrap grouping variable with get, then we do get the right answer coming out the other side, and then that all works. So what does get do? Get takes a string that we feed it, and it interprets that as the object name, and it returns the value of that object. So here if we say get penguin, penguin here being specified as a string, it will translate that into the object penguin, and then it will return the content of that object, which in this case is a vector with the penguin species that I just specified there. We can kind of escalate it a little bit if we want to. So if I say that my favorite animal is a penguin, and then we say get favorite animal, it will get the string that corresponds to favorite animal, translate that into the object name, and then return the content of that object. So this is what we're going to be doing inside our function so that we can specify the variable that we want to use for grouping, get it, and then return the content of that column. So once we've done that, it should work, but we've still got one last thing to fix, which kind of threw me the first time I worked on this one, is that it then couldn't find the object species when it was looking for it for the text box. So at this point, I decided, right, let's go into debug mode, see what's going on. So debug the function, and at that point I noticed that in creating the mean xy data frame, remember that one that we create at the start of the function, it creates a column called get grouping variable, just because of the way that the code works there. So instead, in our code, we need to paste that this is what we're looking for when we're specifying the column name. So previously that said species, otherwise it would say get grouping variable, but we need to specify that actually the name of the column is get grouping variable as a string. So we've got the penguin plot, and we're going to say grouping variable is species. Great. That's what we were already doing. So let's try and do it by island, and it has worked. We've got the names of the islands appearing, but actually we've got a problem in that we've run out of colours. Now this is a good problem to have. We want it to not find colours that correspond to the islands because we only specified the colours for the species. So what we're doing here is we're just adding the stuff that we need to the penguin colours, and then we're also going to add in male and female because I know we're going to try and group by those as well in just a minute. So we've got our colours sorted, and now we can start to add them in. So here we're saying that the grouping variable is island, and you can see that it's found them and that it's doing the right thing. And here we're saying that the grouping variable is sex instead. So we've got the male penguins, the female penguins, and some of them are marked as NA. So we've got the data set sorted, we've got the colours sorted, we've got our plotting function sorted, and it's all looking pretty great. The last thing that we're going to do in this section is just make the labels optional, because as you can see, they were kind of overlapping when we were here. So we're going to add an argument called add labels true. We're going to make the default true, and we're going to then write the code in such a way that if the labels are true, then it takes the unlabeled plot and it adds text box to it. And if the labels are not true, so that would be the else, then it would just return the unlabeled plot instead. So if add labels equals true, take the plot and add some text boxes, else just return it as is. And now we know that this is going to work nicely, so we get rid of the boxes when we don't want them and we keep them where we do. And the last way that we're going to add some parameterization to our plot function is to do with the styling. So we've already played around with the styling a little bit by adding the labels as a true or false logical argument. But I think there's more that we can do. So we're going to try and add a subtitle in, and we're going to say maybe the subtitle default is NA. And again, if the subtitle is NA, then just export it as it is. But if the subtitle is not NA, then we're going to just add the subtitle as we've specified it in the argument. And again, this just gives you more flexibility when you're creating your plots for a report. If you want to calculate something that then feeds into the subtitle, you can do that and everything will work accordingly. So we've got the basic plot here, make penguin plot, and then we're saying make penguin plot with a subtitle, saying that always some exceptions that don't quite match the proportionality that we're expecting. See this little chin strap over here, and it seems to be defying the odds of flipper lengths. So we've got the option of adding in a subtitle if we want to, and you can really go to town with this and and there's many options in there as you need to fit the flexibility of your project. But before I close, I just wanted to share with you just the magic of the 3 dots. So the ellipse here that you can use, and you can add that to any function that you create. And once we've added it in, kind of almost as an argument, it then allows it to be taken by something else inside it. So we're feeding in something up here, and we're telling it to reuse it within theme. And what this means is that we can get creative with what we want to do within the theme. So in this one, for example, I've said that we're going to change the axis text, the axis title, sorry, so that it's purple and it's really big. So we've got the big axis text down here. And here we've got it so that instead we're putting a red border around the rectangle that forms the background of the plot, with a margin around it again. So not super useful as is, just like that, but here's the use case for it. If you are creating different plots that have got different filters on them, and say you've established earlier on that the female penguins are going to be kind of green coloured throughout your report and the male penguins are going to be this dark blue throughout your report, then you can start to add these kind of things in. So you could say, okay, I'm going to filter to just include the female penguins, we're going to group it by island, we're going to add a subtitle that mentions that it's the female penguins, and just to reinforce the point, we are also going to change the colour of the outside of the plot to be the colour that we've used to describe the female penguins all throughout the report. And we can do the same thing on this side in reverse. So we've got the male penguins, and then we've got the male penguin colour coming through as the rectangle around the plot. This is probably the more sensible use case for doing things like that. You might say, why stop here? Well, probably because we're running out of time, but you can apply colours and themes to other plots. Now that we've got those sorted, you can create any plot and call the penguin colours that you've got and call the demo theme that we have, and it should work for you. You can also create multi-part parameterised plots, and there's a blog post on my website on how to do that if you want to look into it. And there are a few extra checks and balances that I've included in that blog post, like tests that you want to run to make sure that you've not had a typo in the filtering of the data, and so on and so forth. Where is this useful in the real world? I thought I'd share a few cases. One is if you're maybe creating a fully parameterised report using Quarto or even R Markdown, you can feed the data in at the start, and then you can create your plots as you go, and it should do the right thing. And for doing that, you would probably create yourself a function called generate report, where you feed it the data, and then you could specify what grouping you want to use, and then it could apply that throughout the whole thing. Or you could have your report and have a grouping section where it's by island, and then the next one where it's by species, etc., etc. I've had fun creating this kind of stuff using WebR, and you can find that at Barsby Write. The last way that you could think about doing this is if you've got colleagues who are more or less comfortable with coding, you could create a Shiny app, and I'm in the process of creating one for one of my clients, where they would just upload the data, select the parameters that they want to group by, and then it would export the plots for them. And again, this allows you to do some pretty powerful visualizations in a way that doesn't really require them to interact with the code. And I think this could be quite an interesting thing to leverage if you're wanting to improve the data to visualization flow, not just for our users, but for other people across the team that you're working in as well. So at this point, really, it's over to you. We've got all the basics sorted. There are other resources on my website that you can look up. If you get stuck, do give me a shout, and I'll do my best to help. But I think for now, all that's left to do is just to play us out.